Hi sir, my name is Claudius Anamoshi. My matrix number is 05 DKM 35F1046 and I will represent to you for question number 1 on workshop technology presentation, which is the types of welding machine, types for GTAW and GMAW, the types of electrode, gas, and also the components. So first, the methods for welding GTAW and GMAW. For GMAW, we use a continuously fed consumable wire electrode, where the electrode melts and joins metal through an electric arc formed between the wire and the workpiece. This process can also be either semi-automatic or automatic. For GTAW, however, it uses a non-consumable tungsten electrode, which means that the tungsten, it doesn't erode. You just need to sharpen it, and also this way it will create the arc where the arc melts the base metal and a separate filler rod is manually fed to your liking into the weld pool where it provides a precise, clean, and high quality weld. So next we will talk about the welding machine for GMAW. So for GMAW, the power source, first thing first, we have the power source which gives it a constant voltage output. Next is the wire feed unit that pushes the electrode through the welding gun. Then we have a welding gun or torch that can deliver both the wire and shielding gas to the area at the same time. And lastly, we have ground clamp unit, which will complete the circuit so that the arc can form. And then next, we have welding machine for GTAW. For GTAW, there will be a constant current power source that gives a constant voltage output. Either can be alternating or direct current. And then we have a thick torch that hold the tungsten electrode and delivers a shielding gas. Other than that, we also have foot or hand control to adjust the current while welding. And then lastly, we also have a ground clamp unit to complete the circuit. And then we have types of shielding gas for GMAW. So first thing can use is pure CO2, where we use it when we want deeper penetration and it's cheaper. Other than that, we can use argon and CO2 mix. This is for smoother weld and produce less spatter. And then lastly, we have pure argon, which is used mainly for non-ferrous metals like aluminium. And then we have GTAW. So types of welding gas for GTAW is we only have two. Either pure argon, which is used commonly, and then we have the argon and helium mix. So it's also called argon helium mix. This is for deeper penetration and higher heat. So this is the types of electrodes for GMAW, and as you can see, so we have this wire spool. So this will provide the electrode, the wire electrode for the GMAW. So it uses a solid consumable wire. Either can be ER70070S6 for carbon steel and ER4043 for aluminium. And then we have types of electrode for GTAW. So for GTAW, we have pure tungsten green tip, which is used for AC welding, usually used for aluminium. And then we have thoriated tungsten, which is green, which is used for DC welding, usually used for steel. And then lastly, we have serrated or lanthanated, which is used for multi-purpose and much more durable work. We will then go to the next presenter.
Hi, my name is Nathanuel, and now I'm going to talk about question 2, which is discuss the type of current and polarity used in both GMAW and GTAW, and effect of polarity on the welding process. So, the first one is GMAW. The current type is DC, polarity DCEP, which is electrode positive. So, the effect is first, good electrode melting rate, stable arc, and acceptable penetration. The next one is GTAW with current type DC, polarity DCEN, which is electrode negative. The effect on the welding process is concentrate heat on workpiece, deep narrow penetration, and longer tungsten life.
Hi, my name is Trivestian. and today I'm going to explain about advantages and disadvantages of gas metal arc welding and gas tungsten arc welding with other welding methods. So first is GMAW. The process involving is a continuous wire electrode with shielding gas. The advantages of this method is it has a high welding speed and deposition rate because it uses a continuous wire feed which allows faster welding speed than GTAW. This method also easier to learn and automate, and it's very ideal for automation and semi-skilled operators. However, this method is not suitable for field work because the gas is easily blown by winds, or let's just say it's not great for windy conditions. Lastly, this method is less portable because this method requires a gas cylinders and power supply to operate. Next is GTAW, which is gas tungsten arc welding. This process involving a non-consumable tungsten electrode and a separate filler metal. The advantages of using this method is it produces highest weld quality, because it produces clean, precise, and defect-free welds. Next, it also has an excellent control on thin materials, which is very ideal for thin materials and proper joints or critical joints. And however, this method has a slowing speed, which is not ideal for large scale or thick material productions. This also requires a high operator skill, which needs an experienced welder for proper control. Lastly, this method is not suitable for outdoor conditions because gas shielding is disrupted by windy conditions. Next is comparison with other methods. While for GMAW, it has a very fast welding speed and easy to use, but less portable since it uses or require a gas cylinders and power supply. Next, for GTAW, it has an excellent precision, but it has a slower welding speed and more skill dependent since it requires a high skilled operators. For shader metal arc welding, it it's great for outdoor and also for thick materials production, but requires more cleanup since it produces more slag. For flux core arc welding, it has high speed welding and also great for outdoor, but produces slag and smoke, and also not great for windy conditions. Well, in conclusion, GMAW has a better productivity and ease of use, while GTAW has a great precision and good weld quality, while for shielded metal arc welding and flux core arc welding, it has a great versatility and better outdoor use. And lastly, by selecting the right method, ensure the strong, clean, and cost-effective welds.
Now I'm going to talk about question 4, which is to identify common welding defect and the prevention method. So the first one is undercut. How to prevent it is reduce current or voltage, correct treble speed, correct touch angle, and use proper filler wire technique. The second one is lack of fusion, which is incomplete fusion. How to prevent it is increase heat input and reduce treble speed, correct touch angle, and use proper joint preparation. The third one is lack of penetration. How to prevent it? Increase current or preheat, correct joint preparation and root opening, and use proper technique. The fourth one is crack. How to prevent it is to control heat input and cooling rate, use proper joint design to reduce strain, and use low hydrogen electrode. The next one is excessive penetration. How to prevent it? Reduce current or voltage, increase treble speed, use backing bar, take and feed up control. And for the last one is well contamination. How to prevent it is to clean surface, use proper filler storage, avoid touching tungsten to well pull, regrind or dress tungsten correctly.
Hello, sir. My name is Paarvin Rajendra. My matrix number is 05DKM25F1063. And today I'll be talking about distortion in welding and method to minimize it. Let's start with the basics. Distortion in welding means an unintended change in shape or dimension of a workpiece after welding. It mainly happens because of uneven thermal expansion and contraction when the weld metal and base metal heat and cool at a different rates. These uneven movements cause metal to pull, shrink, or bend, leading to distortion. Why does it matter? Because distortion can reduce dimension accuracy, cause assembly problems, and even lead to stress concentration or failure in structures. Now, let's look at the 5 common types of distortion that can occur during welding. 1. Longitudinal distortion. This happens along the length of the weld, usually in long butt or fillet weld. 2. Transverse distortion. It occurs across the weld, causing the joint to shrink or spread sideways. 3. Angular distortion. One side of the joint tilts more than the other, creating an angle at the weld. 4. Bowing or twisting. A gradual curve twist forms because uneven weld spacing or heat. 5. Buckle, sudden out of plane deformation, often seen in thin panel due to compressive stress. Each type affects the weld structure differently, but they all reduce overall accuracy and quality. Next, let's talk about what are the causes of distortion and how to minimize it effectively. The key solution includes uneven heating and cooling, too much heat input, for example, using excessive current or welding too slowly, poor welding sequence like doing long continuous weld, bad joint preparation or loose fit up. Now, to reduce or prevent distortion, here are some effective minimization methods. Use proper tack welding to hold alignment. Apply clamps and fixture to resist movement. Follow balanced welding sequence such as backstep, skip, or symmetrical pass. Control heat input by using lower current and faster travel speed. Preheat or post-weld heat treat when necessary to balance stress. And lastly, make sure joints are correctly designed and tightly fit. By following this method, we can greatly reduce distortion and produce stronger, more accurate weld. In conclusion, distortion in welding is caused by uneven heating and cooling. It can take many forms, from angular and longitudinal to bowing or buckling. But with proper preparation, control of heat input, and correct welding techniques, distortion can be minimized effectively. It's all from our group. Thank you very much and have a great day. Bye bye.